So this is chapter 12, section 1, and it's on what causes air pollution. So the objectives today are to name 5 primary air pollutants and give sources for each, to name the 2 major sources of air pollution in urban areas, to describe the way in which smog forms, and to explain the way in which a thermal inversion traps air pollution. What causes air pollution? So air pollution can formally be defined as the contamination of the atmosphere by waste from sources such as industrial burning and automobile exhausts. So most of us kind of have a kind of common sense, intuitive feel for what air pollution is. It's stuff that comes from our cars. It's kind of that smog that like hangs over certain cities. And all that's correct when you think of air pollution. It's important to note that air pollution can be in different, all different forms of matter: solid, liquid, and gas. Where solid's going to be more of things like dust, pollen, spores, like more solid type things, and then liquid's going to be that can be like kind of acid rain. It would probably be the biggest one. And then gases are going to be your sulfur dioxide, nitrogen dioxide, carbon dioxide, carbon monoxide, and so forth. And it's important to note when you talk about air pollution that not all of it's caused by human activities. There are some natural causes. Again, like dust, pollen, spores, these are the types of things that give people a lot of allergies. And then sulfur dioxide comes from volcanic eruptions. So just some terminology. A primary pollutant is going to be something that's directly caused by human or natural activity. It's like whenever you have smoke and you get soot from that smoke, that's a primary pollutant coming directly from that smoke. Then you have a secondary pollutant, which comes secondarily. It comes from a chemical reaction that occurs with the primary air pollutant. So the best example is going to be ground level ozone that would come from the exhaust from your car that combines with the sunlight. And I'll show a diagram of that later on. So speaking of ground level ozone, that's going to form whenever you have emission from your car that reacts with the UV rays of the sun, and then that will mix with the oxygen in the atmosphere to create ozone, which is O3. So oxygen is as most of us are familiar with, is O2. It's basically the mixture of reacting with some of the nitrogen and sulfur oxides from the car will add an extra oxygen to this O2, and then the sunlight will kind of cause it to be able to go from O2 to O3. And this is a chart or a table just showing what it looks like for different types of primary air pollutants based on different sources. So the biggest one's going to be transportation. That's where we get most of our air pollutants, especially carbon monoxide. So carbon monoxide is going to come from the incomplete combustion. So the combustion engine is what our cars run off of, at least our cars for right now. And whenever that reaction where you're burning your fuel if that doesn't happen completely efficiently, you form carbon monoxide. And carbon monoxide is an air pollutant. It's something that we don't really want a whole lot of in our air. Particulate matter is another big source of air pollution, and that's as the name might suggest, it's particles. It's more of solid type things. So like little tiny particles of dust that can get inside your lungs and irritate it. And then you have your nitrogen oxides and sulfur oxides, which kind of have a similar role. And then these things called volatile organic compounds. So volatile, if something's volatile, it means it can go from liquid to gas very quickly. So if like you're talking about a human and I said, oh, that person's really volatile, that they get angry really quickly. So in a similar way, a volatile organic compound is a compound that it goes from its liquid state to its gas state very quickly. So gasoline is is a VOC. It's a volatile organic compound. It goes from liquid to gas really quickly, as when you pump your gasoline in your car. Nail polish should be a VOC. It goes from being liquid whenever you paint it onto your nails, and then some of those organic compounds will go from liquid to gas very quickly, which is why they create a lot of fumes. Same with paints. In the electricity production, you get a lot of sulfur dioxides, nitrogen oxides, and a little bit of carbon monoxide. So some of the sources of our primary air pollutants are going to be almost kind of everything that we use, truthfully. So like even your household products, a lot of your household cleaning products can have volatile organic compounds. Power plants are a major source of power plants, refineries, and metal smelters are a major source of the sulfur dioxide. Motor vehicles are going to be, as you said, a big source of the carbon monoxide. So you can kind of refer back to that graph to get an idea of the rest of them. Talking a little more about the particulate matter, you can get really fine particles that can form the particulate matter that come out of your vehicles and coal burning power plants. Also cement plants, mining operations. So kind of really, there can be sort of a common sense element when it comes to thinking about air pollution, where, if you have a wood burning fireplace, like, it's, like you look at that smoke coming up there, you can imagine that there's little tiny particles that make up that smoke. And this is a really good review table that I won't, bore you by reading all the, each box at a time, but it's kind of something you can refer back to. History of air pollution. So when we think of air pollution, we typically think of this as like this modern day, industrial revolution problem, but the reality is that air pollution has been around for, most of recorded history. An example that they gave here was in 1273, you had King Edward that ordered that people stop burning what was called dirty coal, which is this sea coal that just produced a terrible amount of air pollution. So the idea of burning coal, like burning things, and that producing air pollution isn't just something that came around once we started driving cars. Driving cars just made it a lot worse. And most of the air pollution that's coming out of our urban areas is coming from vehicles and industry, which is kind of obvious when you put a little bit of thought into it. Motor vehicle emissions. About 1/3 of air pollution is going to come from the gasoline burned from our vehicles, and then some stats on driving is here as well. So to help control vehicle emissions and fix this problem, because vehicle emissions are, as the previous slide said, 1/3 of all of our air pollution, the Clean Air Act was passed in 1970 and then strengthened in 1990. And this basically just gave the government some authority to help regulate and try to, figure out this problem of air pollution to some degree. One of the biggest successes of this legislation was the ability to gradually eliminate lead from gasoline. So whenever you go to the gas station, it'll say unleaded gas. And when you think about it, like, some people may not know what that means, and unleaded, it means no lead in your gasoline, and that's referring to a time where there used to be lead in the gasoline, and lead is a really, really, really terrible toxin for the body. Especially for younger kids as they're growing up. If they get lead in their bloodstream, it's called a neurotoxin. So it goes to the central nervous system, the brain, spinal cord, and it'll really interfere with the cognitive, brain development of those children. And so, we're burning lead, gasoline that had a ton of lead in it, so we would be releasing all this lead into the atmosphere, and people, and especially kids, would be breathing that in. But fortunately, they're able to slowly kind of get rid of all the lead in the gasoline and reduce it nearly to where there's none. There's probably little tiny amounts in it. Another big thing was adding what's called a catalytic converter into automobiles. And basically, a catalytic converter is just a little attachment that's at the very end of your exhaust pipe that helps to filter out some of the pollutants that are coming from the exhaust out of your car, so that they don't have as many of the pollutants. This might seem kind of random, but it's just another example of really of a big legislative program, and it's the California Zero-Emission Vehicle Program. So, in 1990, California Air Resources Board established this Zero-Emission ZEV program. So, a zero-emission vehicle it's just a vehicle that has zero emissions, no tailpipe emissions that come from gasoline. And the emission control systems in the vehicle aren't going to break down over time. So these vehicles are going to be powered by hydrogen fuel for the most part, and they're really going to only eliminate water vapor, which is kind of cool, but most of them are in the prototype stage of development, at least when this PowerPoint was made, roughly 6-something years ago. So the biggest thing is they're expensive. That's kind of the kicker with anytime we're talking about energy resources and environmental sciences. We might be able to have clean energy, but that sometimes isn't the issue. The issue is making it affordable for people, because the reason why we burn coal and we do all this stuff is because it's cheap and it's easy to get at. Whereas if you want to have an electric car or hybrid car or whatever, it takes costs money to do that. So this program kind of inspired other states, Maine, Massachusetts, New York, Vermont, to develop their own programs to try to get these zero-emission vehicles into development. Kind of as I've sort of alluded to, we need to burn fuel to get the energy we need to do life, to make the products that we use in industries, to do all the stuff we do at our house. But in the process of burning those fossil fuels that we use, we generate large amounts of sulfur dioxide and nitrogen oxide into the air. And power plants are going to provide about 2/3 of all the sulfur dioxide and 1/3 of all the nitrogen oxides into the air. Some common VOCs are going to be from dry cleaning, oil refineries, chemical manufacturing plants, furniture finishers, automobile repair shops, some of the household cleaning products. And again, a VOC is just an organic compound, so something that's made of a lot of carbon, and it's in its liquid form, and it goes from the liquid form to the gas form very quickly. Another thing the Clean Air Act helped to do with regulating air pollution from industry is to use what's called a scrubber. So a scrubber is a pretty cool, kind of nifty little device where you have dirty gas that comes in right here. And this dirty gas we spray with water, because if you spray the dirty gas with water, it makes that gas heavier, where it'll grab onto all those pollutants in the air, and then it'll drain out that dirty water that has some of those pollutants. And then that gas will still have some pollutants in it, but then you have a filter up top here that can remove, hopefully most of the rest of those pollutants, so that coming out of the industry is just going to be cleaned gas, or cleaner gas, at least than the dirty gas that's coming out of it. Another example is what's called an electrostatic precipitator. So these are used where you have gas, just like in the previous one, that has these dust particles, and we run these dust particles through an electrical current. So that electrical current is going to give an electric charge to each of those dust particles. And because they have an electrical charge, they're going to stick together, and they'll stick to the sides of the chamber, which will, if they're sticking to the sides of the chamber, then you can then kind of wipe that out of the chamber, and then the gas that doesn't have those particles anymore will flow on out and go through a filter, kind of like what you saw in the scrubber. So anyways, just two kind of examples of different filter type things that we can use to clean the air. So smog. I'm going to go ahead and jump to this slide right here to talk about smog. Where smog, the most common way it's formed is going to be from our automobile exhaust. So this automobile exhaust has all kinds of pollutants in it, where the sunlight is going to, some of the pollutants are what are called your oxides, so your sulfur oxides, and your nitrogen oxides, so NOx, and ozone, which is called O3. So what happens here is you have oxygen, O2, and sunlight is going to go, these rays are going to go and they're going to hit these nitrogen oxides, and they're going to cause a reactive oxygen to break off of these sulfur dioxides and these nitrogen oxides. And this reactive oxygen can then go and attack this normal oxygen and create your ozone, the O3. And then this ozone can then kind of go up, and it's what's forming the smoggish, hazy kind of layer over certain cities. And ozone isn't, ironically, it isn't actually a bad thing if it's at a higher point in our atmosphere. So, towards the outer layers of our atmosphere, we want ozone because ozone can actually block these UV rays from the sun. However, whenever ozone is closer to the Earth's atmosphere, where we're living at, that ozone is going to be something that's toxic to us, and it can really irritate our lungs. The final big idea here, and I'll just jump to this picture to explain it, is what's called a temperature inversion. So if you look at this normal situation here, normal weather, normal day, you have warm air. And warm air is going to go from where it's warmer to where it's cool and to where it's cooler. Should make sense. Things go from where it's warmer to where it's cooler. And because the air is set up like that, pollutants are going to naturally want to, follow the air, follow the cooler air, and it will more or less escape from the atmosphere. With the temperature inversion, though, so if you're located in areas that are kind of surrounded by a lot of mountains, or that are in a lower lying area, kind of in a basin, you can get these temperature inversions where rather than having the warm to cool air, you have cool air, sandwiching a warmer layer of air, where this warm layer of air will essentially, it'll literally be like a ceiling. It'll block in these pollutants, and they'll get trapped into the region. So you see this a lot in Mexico City, or just in Mexico in general, because it's surrounded by all these mountains. You can get these temperature inversions, and it can really, really make the problem of smog and air pollution that much worse if you have the wrong kind of weather patterns for the day. Okay, so I'll do it for this section.